Hey everybody, what a crappy day it was yesterday. I bet some of you appreciate having yesterday off last night because the weather was so nasty, and I know some of you are coming from like Toronto and stuff like that. For example, one of the guys that I work with, he took 3 hours to get from Toronto to Barrie last night because the roads were so terrible and everybody was driving so slow. So normally I don't call it off, and I'm pretty good with most weather, but last night was just, yeah, it was a little too much. Okay, so tonight I'm gonna quickly do this lesson. It should go fairly fast because there's not a lot to the lesson. However, I would recommend taking the information that I give you, help augment that by going and reading more on MDN or through watching videos on YouTube and that kind of thing, so that you can get a better understanding of what we're going to talk about tonight, which will be objects that we're going to talk about. Now, you should, for the most part, you guys have used objects and you understand what objects are because you come from class-based languages like Java and Objective-C. No, wait, you guys don't use Objective-C. I think you guys use C# or ASP.NET, which I believe you guys are using C# for as well. Those languages are a little bit different when it comes to objects than it is in JavaScript. In JavaScript, you're not really instantiating the objects from a class. So you don't create a class and then instantiate the object. The object just kind of is there. It exists immediately as you create it. So a little bit more like, I would say they're closer to being like structs than they are like, I don't know, like instantiated objects, right? Because they're just like an instantaneous object that exists. So that's not really a struct either. Anyways, the point is that part tends to throw new JavaScript programmers off because they're expecting to have to create a class and then instantiate the object from a class. But you don't do that. You just create this object. Now, that doesn't mean that you can't create new versions of that particular object, because you totally can. But the object is usable immediately, unlike a class where once you create the class, you can't just like start referencing the class and adding new properties and methods to it programmatically. You have to actually like hard code that stuff in. Whereas in JavaScript, once you create this object, even if it's just like an object template kind of idea, you can continually add new properties and methods to it programmatically if you so choose. That's one of the very big powers of JavaScript. Alright, so why don't we get into the lesson? If you click on Weekly Learning, the lesson is up. Now, I believe these due dates are a little messed up. The due date for the lab and the quiz, I think the quiz is set for tomorrow. I'm going to extend the lab by 1 week, and I'm going to extend the quiz by 1 week. So it will be due. You do need to watch this video, which I'll post an announcement for. And then, yeah, you definitely need to make sure you get that quiz done before next week. Alright? Okay, cool. So you can click on the object literals and constructors lesson. That'll take you to the lesson itself. This is another interactive lesson, and the cool thing is I have ironed out quite a few of the bugs. So hopefully this works out the way I want it to. I feel like not all of you are a big fan of this thing, but for the most part, I think it's definitely beneficial compared to having to type in an ID and not necessarily getting the feedback that you need from the error handler. This is a little bit clearer. We don't need to quite that big. Let's go like that. Move this over a little bit. Cool. Alright, but before we talk about objects, we're going to talk about debugging in JavaScript. So we've been using this console window over here. We've used it quite a bit to this point. You should know how to open this console window. If you forget, you can definitely look it up in week 2. In week 2, we use the console window. I do believe I actually have that published somewhere. Yeah, I think it was week 2 that we actually looked at it. Let me just double check. Yes, the Mighty Console, there it is. Yeah, right, so in week 2 there's this wonderful table here. In here it tells you exactly how to open up your particular console window, right? So for Chrome, if you're on a Mac, it's Command-Shift-J. If you're in Windows, it's just F12 or Control-Shift-J. And then the other browsers have their own different implementations of how you actually open the window as well. So just keep this for reference because you will be using the console quite a bit. If you forget how to open up the console and for whatever reason it's closed, you can always go through the menu and see if you can find it that way. Like, I can't remember actually what one it's under. It's under Developer. Right, so you go to View, Developer, JavaScript Console. In some browsers it might not be under View, it might be under Tools and stuff, so you may have to take a look around. But then again, there's always the mighty Google, right, which you guys should be dedicating some time to mastering so that you can look up how to do these things, like how to open up a console and stuff like that. Alright, so now the console is pretty cool because not only can you type JavaScript in it like so, right, x equals 5, window.x is 5, you know, whatever you want, function greeting do console.log I greeting. As you can see, it's like a full-fledged IDE. Now, you obviously don't get, like, you kind of get syntax highlighting, but you don't get to the ability to duplicate a line or, like, multi-cursor or any of that kind of stuff that you get in an IDE. But you do get hinting, which is fantastic, right? Like, when you type in an object, for example, and press a dot, you get a list of all the properties that are available on that object. And as you can see, there's tons and tons of them on the window object. So you do get hinting, but not hinting in the sense that if you call a function, that it will give you the parameters it's expecting, right? So if I have a function, for example, like say I want to do map, and I was just to call map, and I go like this. Oh yeah, it does actually. Yeah, no, I'm wrong. So it needs a callback function, and it can also take an args function as well. So yeah, I'm wrong. It does have syntax hinting. So you could use the IDE as a way to do that, but your IDE itself is probably a lot better than the console IDE. However, that's not the only purpose for this. The other purpose for this is it allows you to debug your particular JavaScript as well, right? And often an error message will show up here, and it may be confusing, and you may not fully understand what the error message actually means. Like, for example, if I try to call add, for example, right, I don't actually have this defined. Add is not defined anywhere in my scripts or my program, so I get this error message, uncaught reference error, add is not defined. So if I was to break this apart a little bit, this thing is called your error message. This part right here is your error message. The next piece tells you what file your error message is in. It tells you what line it occurred on, and it even tells you what character it started to create the offense, basically. If you get this little pink bubble, sometimes you get this wonderful error here, and if you open it up, it opens up what's called the stack trace. The stack trace is basically it should help you find the root of whatever the problem was. So you can start at the file that actually created the error, but then you can slowly work through the other files and see what file initialized the whole process in the first place. All right. So now I did program over here. I've got this console log whosit.length, and whosit isn't defined, and I'm attempting to try to call it. I'm actually attempting to try to call a property on it. So it's going to actually create a problem. It's going to blow up, and we're going to see it over here. Now, because I'm running this evaluation software in the background, I catch these errors, so they don't come up pink like this, unfortunately. But they do get destruction. You do see what happens. So if I click execute, you'll see uncaught reference error, whosit not defined at 1, so line 1, character 13. So if you count them, it's 0, because it's indexed by 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then that's character 12 or whatever. So it's not exactly accurate, probably because of me formatting it, but you get the idea that it's definitely somewhere within this code line at least, right? And it tells us this piece, which is our file, right? Now, what I've done with these is this is module 4, and this is practice 1, is what that essentially understands. So if you get this error and it says M4P1, then this is in the practice 1 bubble on line 1, character 13, where the reference error occurs. Now, uncaught reference error basically means that we're not using a try-catch to catch it. in any way, so it's actually going to halt our application and stop it from running further. Which, that means we definitely have to take a look at it and figure out what the problem is and then correct it, right? So in addition to having these wonderful error messages pop up for us that we can actually use to decode and kind of figure out where our problem is and then go and correct it. Like for this one, if we wanted to correct this error, what we can do is we can go, okay, well, who's it obviously needs to be defined. So we'll just do let who's it. And we'll just give it a random thing. We'll just say, hello, everybody. So, and now if I execute, the error will go away, and we'll actually see the 15. All right? So there we go. We've resolved our issue. There's no problem anymore. All right, so debugger. So JavaScript command debugger allows you to take, basically place a breakpoint within your code. So some IDs allow you to click the line number, and that will create a little breakpoint, like Visual Studio does that. But unfortunately with JavaScript, you don't have that capability. Well, not entirely. Like you do. What you can do is you can come over here to these arrows, click on sources, and you can see all of your code here. And you can actually click on a line and create a breakpoint at that particular line, right? But there's a lot of JavaScript in here. There's all of code mirror in here. There's all the stuff I'm running in the background. There's a ton of code in here, and obviously it would make it very difficult for you to figure out where the problem was that way. It's much easier just to type a breakpoint inside your code within your IDE than it is for you to have to fight with the actual source code that's inside there. So what we do is we can add a debugger line. So for example, say I want to know what the value of sum is when it parses through this before it hits this next line of code. Especially if this code happens to be breaking. So if this code was blowing up and I didn't know why, what I can do is I can add a debugger here where I know the code is still operational, evaluate what is occurring here, fix it, and then remove the debugger, and hopefully my code will parse properly after that. So to do that, I just add the word debugger. That's it. Nothing huge. Like execute here. And the whole window will pause, and it will tell you, paused in the debugger. And you can press this little button to continue, or you can just do what it's asking you to do. So if we go to console, it says we want to, using the debug state, access the value of sum and set the following variable to that value. So we can actually evaluate sum by just typing sum right inside here and hitting enter, and we can see that sum's value is 1,538, right? So if I click play, what play will do is just move on and continue to execute the script until it hits the next line, like the next error, or sorry, not the next error, the next debugger that's in place. Your other option that you have is to actually step into functions. So this will step over the next function call or step into the next function call. So if you put a debugger within here, you can step into this for loop, and you can keep running the debugger within your for loop, and then when you want to exit out, you just click step over, and then that will execute outwards. Right? So the debugger is very, very handy. So we're going to add the debugger, and then we're going to type in what it's looking for, which is 15. What did I write in the console? 1538. So 1538. I'm going to hit execute. I'm going to hit play. And if that's correct, it should just have passed. Alright? Cool. So that's kind of like a super fast intro into debugging into JavaScript. There are more that we're going to look at, like how to deal with error handling in JavaScript using try-catch and being able to throw our own errors and stuff as well. Even something I found out recently, which is called the window.on error, which is an event that gets cast when an error that is uncaught occurs, which is pretty cool. That's actually what I'm using in the background here to be able to tell us when an error has occurred. But yeah, we're going to take a look at those in a future class. Probably another one of these other intro blocks. All right. But yeah, let's move on. Let's talk about objects. So it's a bit of a recap, right? Like objects in most languages, they're basically a way for us to encapsulate code underneath an idea, right? So we use functions to encapsulate an action or some sort of abstracted logic. We can use a function to basically place that underneath a namespace. But we can do the same thing with an object. We can encapsulate lots of functions and lots of properties and variables underneath a bigger namespace. But usually we want all of those methods and properties to kind of have a correlation to whatever the object is, right? We don't want them to just be random. They should kind of follow the same idea. And the way I like to think of objects, I usually like to think of them like they're a noun, like a person, a place, or a thing, right? So you could have an object called bank account, right? Or an object called person, or an object called student, for example, because they're encapsulating this one idea. And the properties that you have inside the object, like say for a bank account, if you have your account number, that would be considered a property. I kind of consider those to be like adjectives. They're like descriptive words, things that kind of describe the object more. So if you had a person, you might have name or age or hair color or height, weight, whatever. Those are all kind of like adjective type words. They're descriptors. They're state properties, right? And then if you take a look at like methods are a bit different. They're more action based. It's like things the object is capable of doing. Actions the object can do, right? So they tend to be more verbs. So things like talking, walking for a person, or if it's a bank account, it might be deposit or withdrawal. It's always action-based. And I find by thinking of an object in that kind of format, it's much easier to grasp the concept of what an object is. It also helps me when I'm labeling out their properties or their methods, to get a better understanding of what this particular thing is. These two things that you see here, they're objects actually defined in JavaScript. These are object literals. So this one here says let person. It has 3 properties. It has a name, an age, and then an array of interests, right? This one here has those same 3 things, but then it also has some methods in it, right? So it has the talk method, which is assigned a function definition here. That's basically just console logged out the age. And then it has a walk method as well, which is really just changing the x-axis of whatever the object is. Pretty simple stuff. So the whole adage, everything's an object in JavaScript, is obviously misleading because not everything is an object. There's also these things called primitives. And the primitives inside JavaScript, they're like the built-in pieces that you see that you use. So primitives in JavaScript are booleans, strings, and numbers. Those are primitives. Also null and undefined are also primitives. Primitives are not objects when they start out, but they generally get cast to an object. Okay? So for example, if I have a string called Sean McKinnon, this thing is a primitive. It's not an object. It doesn't have any methods or properties or anything on it. It is a literal string. That's what it is. However, the second I add a dot, you'll notice all of a sudden I get this list of properties that are available to this string and a bunch of methods as well. And the reason that is because this primitive immediately instantiates a new string object and puts this in as the argument to the constructor and returns that string object. It happens in a fly. The second you press dot, that whole operation has occurred. And now you have the ability to access these things, but this thing has become a string object. It didn't start as a string object, it has become a string object. So that's partly the reason why people get confused and they say everything's an object. It's because when they go to access the methods or properties on these things, what's happening is it is immediately getting casted into its object version of itself, and you get to work with that object. But they are technically primitives, and they're not objects, right? So that includes for Boolean, strings, numbers, null, and undefined. It's only these 5 things. That's it. That's the only things you have to remember. It's just these 5 things are actually primitives. Arrays are objects. Objects are objects, obviously, and then functions are also objects. Those 3 things are objects. So we also have these things called built-in objects, and there's quite a few of those. We have this list of things called data objects. So data objects are objects that already basically exist. So like string is an object, and it will create a new string, as you can see there. right? So if I put string, I put Sean in here, it'll return a new string object called Sean. And then I have the ability to work with that. Now that creates an object the second I do that. So if I say n equals Sean, n is now an actual string object. That's what it basically is. And I have access to all the properties and methods that are on that. Number, same thing. If I do the same thing with number, and I pass like 5, I get back a 5 number object, right? And I think I can actually see that if I do constructor.name, it will tell me it is a number based on the constructor of it. Boolean, same thing, array, same idea, object, the same idea, and the function. Now, string, number, Boolean, array, and function, they actually all inherit from the base object. Object is the root of absolutely everything we'll ever do. It is the most low level that you can possibly get in JavaScript is object. And string, number, Boolean, array, and function all result back to object. They all inherit from object at some point. All right? So we can also see what properties an object has if we're curious by using the getOwnPropertyNames method. And we call that on the object itself. So we call object, right? So just object. We use getOwnPropertyNames like so. And then we just pass it the object, whatever that is that we want to actually use. So if I want to use string, I just pass it string. And as you can see, there are 6 properties that are available on the string object. And that is length, name, prototype, from car code, from code point, and raw. That's what happens to be attached to this particular string. Now, we haven't talked about proto yet, and we're going to talk about proto next week, but if you click proto, you can kind of get to see what it's actually inheriting from. All of these methods are also available to that string object. Every single method you see here is all available to the string object, and that's because this particular string object is inheriting from the array. Remember how I was saying before, a string is just basically a character array? That's entirely true. So you gain all access to all of the array methods that are available. And then you'll notice there's another proto object, and that is object. And that's the base object. And it actually doesn't inherit from anything because it is the root of everything we work with. And we can see that even on other ones as well if we type in function. Oh, sorry, close this stuff down. We'll type in function, like so, hit enter. Let's do the object get property names function. There we go, and it's got 3 capable for it. So prototype is 1, and we'll be talking about that next week. But as you can see, function also inherits from array and has all of these methods available to it. And then the proto, it comes back to the point of the object. So that's kind of an important thing to understand, that everything basically roots back from object. So we can actually see all of these. If we want, all we have to do is hit execute, and we can see this list here. We can see array has 6 different different properties available to it. Boolean's got 3, function has 3, number has 17 available to it. Then there's object, and then there's string. And you might say, well, that's not true. These things have more. I know they do. Like array's got tons. It's not just these things. And that's true. It has a bunch of functions that it inherits as well from the proto, right? And that comes from the array object. These all come from it and serve back to array. Now, there's a big one, actually. We talked about the math library last week, and we can actually see the math library and all of its available properties if we type in object, getOwnPropertyNames, and then we just give it the math object, like so. Hit execute. And we're not going to see anything. We need to console log that out. So console.log math object properties, like so. And we'll hit execute, and you can see there's 43 little properties available on that object. So there's abs, acos, there's seal that we used, there's round, there's random, right? There's tons. And then they all inherit as well from the array, right? Oh, of course they inherit from array. I'm being a doofus. It's because it's returning an array. That's why it has all of these array methods available onto it. So it's not inheriting from the array. It is an array. Sorry, my apologies. I didn't think that one through. Actually, I think if we do dir string, yeah, there we go. If we do dir string, we can see these are all of the particular properties that are available on the dir string as well. And we can see that it prototypes from function because this is technically a function. So it prototypes from function, and then that prototypes from the object as well. Anyways, big point is that objects have properties and methods. That's the most important process there. Let's talk a little bit about the window object. The window object is automatically instantiated when you actually open your browser. It contains all the functions and variables you create at the global level, not using let or const. It also contains all the built-in browser JavaScript API objects and methods. In fact, there's almost 900 of them in total. You can see that if you do the object.get own property names, like so. We'll put in window, and then we'll just do a count. Or sorry, a length. Like so, and on this one there's 911. And part of the reason why there's 911 is because we've already instantiated some new variables and some new functions, so those are getting picked up inside this number as well. So there's quite a few. The window object is extremely important because everything kind of pulls back from it. Like every variable we create using var at the global level gets immediately added to it. All the functions we create at the global level automatically are added to it. All objects that we create are also added to the window object immediately. So everything is basically there. And we can see that if that add function that we added earlier should be here. Yeah, there it is right there. And you can see that it's not a function. But I think I also created a greeting function too, didn't I? So we can type in greeting, and there's the greeting that we typed in earlier, and it's attached to the window object. So the window object is pretty crucial to knowing that it exists. And we can actually see some more of that too. Like you can copy these ones. These ones have been defined with var. So because it's been defined with var, it should definitely be attached to the window object. My ludicrous var, as you can see, it's on the window object, even though we just defined it at our root. We can check this function. Let's do this function as well. There we go. And then we'll call it as well. So window dot my ludicrous func. Now, if I just hit enter, we're just going to get the function definition, which is what we talked about last week. That the difference between the definition and executing it. We need to use these parentheses, which is like an operator that basically executes the function. And if we hit enter, then we just get undefined. So we can actually pass some values into it. We'll pass a value to ASDF 45. There we go, ASDF 45, which is executing this line of code, obviously. All right, so that is that, and you can click execute, and you can see this stuff get spit out as well. So the next object that I want to talk about, so we talked about like the string, the number, boolean, all those objects. We talked about the window object a little bit. Let's talk about the document object. Now, this is a huge part of what we learn in JavaScript when we're working with client-side scripting, is the document object. It's created immediately when the browser initiates. Every website you go to has its own DOM, and you can work with that DOM to access different elements within that page. So the DOM basically is your entire HTML page converted to an object. And I know that's like a little bit hard to grasp, but essentially, imagine if the HTML tag you wrote, well, it's not actually at the HTML tag, but imagine the body tag that you wrote became the beginning of the object, right? And then that object had a bunch of properties underneath it, and each of those properties were things like your divs, your spans. All of those things became different properties available to it as well. And the cool thing about that is it allows us to be able to do some interesting interactive stuff with it. We can listen for things that are occurring, like click events or mouse overs or changes inside our inputs. If somebody changes an input, we can listen for those events that are occurring and then react based on whatever the user has done to that particular thing. We can also change the order of our DOM as well, so we can move things around. Like we can move this button down here if we wanted to. We can change where the location of some of this text is if we so wanted to. We can also do things like I'm doing, where I actually evaluate your IDE and tell you whether or not what you typed in is correct or not. These are all things that we have control over by using the DOM. Now, the DOM is such a massive thing that we're actually going to explore it in a couple weeks, and it takes 2 lessons to get through because there's just so much stuff that we can do between interacting with the actual current website to creating new elements and binding events to those elements and doing some pretty awesome stuff. So for now, I'm just going to give you a slight hint. We're going to just change some information here. So right now, I've got a button, this button here, right? And it doesn't do anything. When you click it, it does nothing. And then I've got this line of code here. This line of code essentially is selecting this button. So this button has been labeled as DOM Demo 1. And I can see that. If I click on the button, I click Inspect. It will open up my elements, and you can see I have a button with an ID called DOM Demo 1, and it says Press Me on the button, right? So what the query selector does is it allows me to select based on a CSS property, okay? So the CSS property that I'm using is CSS selector is DOM Demo 1, right? And query selector is a method that is on the document object. And we can, once again, see how many are actually properties of the document, and there's a lot. There's so many. Why don't we do this and type in document, and then we'll do a count, a length. And it says there's 2, but that's not entirely true. Oh, right, so it's only returning back the actual properties for it. I want the functions and everything that is attached to it. So why don't we do something a little bit different. We'll do dir document. And that should return back everything within our document that it's attached to. There we go. As you can see, we have the URL, we have active elements. These are all the different things that it has available to it. Now, these are all objects as well. Every time you see this little side box, it's an object. And objects inside JavaScript are actually passed around by reference. So what's really cool is this isn't a duplicate of each of these objects, it's just referencing these objects, which makes it extremely efficient. Here's the HTML collection under the document. So here's our HTML tag, and you can see as highlighted, it actually makes this all blue. And if you click down, you can see it's got children. So if you click on its children, it has a head tag and a body tag, right? And you can access those. So you can access the head tag and actually manipulate it if you wanted to. You can access the body tag, and obviously the body tag has children, right? There's a div container, there's our script tags here that are loading in all of our JavaScript. If I click this tag, I can go to its children, and I can see there's a header, there's an HR, there's another HR, and then there's the article, right? Which is what that's in. Click on that one. And I can just keep drilling down and see where all these different things are. Let's see if we can find our section. Here's the section that we're working in right now. And if you click on it, it'll actually even take you back to the elements and show you these different pieces as well. So because you have massive access to being able to select different pieces from inside your DOM and then work with those, you get a lot of control over what you're actually doing with your HTML. Now, the thing is, back when I first took web development, the whole idea was to keep everything nice and separate. So you kept your CSS in one file, you kept your JavaScript in another file, you kept your HTML separated as well. And basically, HTML was the most important part, and it still is, right? It's very, very important. You wanted to make sure that the content that was on the page was readable, it wasn't obstructed in any way. At least that document was entirely accurate and syntactically correct. And then you added on your CSS to create some style and some, niceties to it. And then after the CSS was added, then you came in with your JavaScript and added in some functionality that wasn't supposed to break the page in any way. It was just basically you could add it and people could disable it if they wanted to or whatever. Now that's changed quite a bit with the invention of things like React and Angular, Backbone, Ember, all these other ones, Vue. There's so many different little JavaScript library frameworks that are out there now. Node is now serving a lot of our front end. From the back end, like we have a now JavaScript server that now feeds information to the front end. So the whole idea of having JavaScript operational in the front is expected now. It's not expected that it's shut off or that people have it disabled in any way. you kind of expect JavaScript to exist. So the whole idea of not integrating those things is not necessarily as important as it used to be. I still consider it fairly important. Like your content should still always work. It shouldn't be blocked by different functionality that you've added. However you're delivering that content is totally up to you. If you're delivering that content from JavaScript and having it put on the page, that's totally fine. Just make sure that whatever you're doing for interactivity, that it doesn't block the user or cause the user to have a bad experience. All right, so let's. So right now, like I said, I'm getting this button and I'm storing it inside this button. And you may be curious why I'm using const, because this is going to return a reference to the element on the page, to this button on the page. I'm never actually going to be. I'm never going to modify this variable. I'm always just going to keep this as a nice named reference to this HTML element, right? And this whole object is just going to store its reference into my button, and I'm never going to change that. It's always going to be that reference, so I can keep that as a constant, which will give me a little bit more efficiency in my code. So then if I console log it out, and I click execute, you can see that it spits out the actual button, and if I highlight it, I can see it over there. Now, one kind of weird oddity in Chrome is Chrome, when you hit console log, will actually spit this out as HTML, so you can see it. If you don't want it as HTML and you want to see that kind of object view that we were looking at before, you can type in dir, hit execute, and then you'll get this version instead, which allows you to kind of hit the breakdown and actually see all the properties and methods that are available to it that you can go through. Like there's all the events that are available to it. There's scroll heights, there's tab indexes, there's value, right? The value, the type as well. So you can see all this other information, the text content that is currently making up the word. You can see all this information a lot easier if you use console dir, okay? All right, so step one. Now we've already passed. I don't actually expect you to change this if you don't want to, but it's kind of fun. So we're going to change it from pink. Actually, I'm going to use the flatUIcolors.com. I kind of like this website. It's one of my favorites. And I'm going to make that button kind of nice. I'm going to choose Peter River. Come back to my button. And I'm going to paste that code inside there. And then I'm going to change the text. So it says press me. And I'm going to say, yay, I have been pressed! Exclamation point. There we go. And then this next block of code, basically what it's saying is the button on a click event, so when it's clicked, execute this callback function. And we saw these callback functions last week. This is an anonymous function, right? Basically what's going to happen is once it's done clicking, it's going to execute this function body here, and we'll do whatever logic's inside here. So this button, we're accessing its style, the background, and we're going to apply the color that we just set up here. And then we're going to access the text content property, which is the text that you see inside the button, and we're going to change it to this text here. So if I click execute, this has happened. You don't see anything yet because it's waiting for us to actually click the button. So we're going to click the button, and there you go. Yay, I have been pressed. And you can see that it applies it, and our colors on it, and everything's done. Now also our page CSS is applying it. That's why it looks like it's impressed inside the button there. All right. So these are the most important, these are basically the big data objects that you're going to see, built-in objects that you're going to see. The data objects, the window object, and the document object. But like I said, the document object is so big that we're going to take a look at a lot more stuff in depth with the document object in two classes entirely. One more thing about the window object before I move on. You can actually get some pretty interesting information from the window object. Like for example, you can get some information about the browser from it. So if you type in navigator, like so, and hit enter, it's going to give you some information about the browser you're using. So it's a Mozilla-based browser. Its application name is Netscape. Its app version is 5.0, and it's running on a Macintosh, or that's what it was built for. It gives you some information about Bluetooth, the clipboard, the geolocation, if you've got that information, any credentials that they may have had, the languages they're using, any keyboard information. Like, there's quite a bit of information that you can collect. You can also find the vendor, which is Google Inc. Right? This product is called Gecko. So on and so forth. So you can get a lot of information about the whole window operation itself by typing in window.navigator, which is pretty neat. All right. Let's talk about creating a custom object. So now we've been using objects, we can actually create our own objects as well. The first object we're going to talk about is object literals. Object literals are just objects that are created using the open and closing curly brace. So even if I just type them raw like this, so that's an object literal, I can actually type that with information in it. So I can do name, Sean, age 39, and hit enter, and that's an object literal. It doesn't actually need to be assigned to anything. It is just literally an object. Now, if I assign it to something like person, then this is obviously going to be stored into person from that point on, and we can use, like I said, because they're passed by reference, we can reference to that object at any point. If I want to add properties, it's pretty easy. If you've had any experience with JSON, JSON uses key-value pairs. That's essentially what this is doing. It's key, and then you get a value. Now, the difference between this versus JSON, though, is you can assign functions to your object as well. So you can actually store entire functions directly inside here, which we essentially call methods at that point. It's a property with a function value that is basically a method. All right? So we're going to create a new object literal. We're literally going to create this object literal. So just do equals, and don't worry about this semicolon. That is totally accurate syntax. It's just not, it's not necessarily common. Not many people do it, but it is accurate syntax. So I'm going to type in a name, and I'm going to write a different name. I'm going to write Humphrey Bogart. You write whatever you want. I'm going to say Humphrey is 79. And his date of birth was, I have no idea what 79 from 2019 is. Let's try 2019 minus 79, 1940. Of course it's 1940. All right, so that goes into a string, 1940, and make it the 5th month of the year, and the 6th day. There we go. And if I click execute, everything should be fine. Now I want to see that, we're going to spit that out, so we can actually spit that out. So we're going to do console.log person, like so. And then we can execute, and we can see that. And we can also use that object.get, I don't know what the method is called. It's a get object property names, I think. Oh, get own property names. There we go. Get own property names. There we go. And we'll put person in there, like so, and execute. We want to console log that, console.log. There we go. Now we'll execute. And there we go. We can see our properties in an array list, like so. When we add new methods to an object, it's the same process as adding in these properties. The only difference is instead of the value being a string or a number or even another array or object, we're actually making the property value a function definition of some sort. Now you can do it either write out the function definition like this, or you can define the function outside of the object and then just pass in the name of whatever that function is. So we're going to modify this above object, right? So that we're going to create a new method called bio and have it basically return this message. So I'm going to just copy this message, like so. And then we're going to create a new property called bio. Only this property is going to have a function definition, like so. And it's going to return this. Now, interestingly enough, something that is extremely important to understand is the context of this word that you see here called this. And this, basically, what it represents is this object, this whole object that you see right here. It's the contained, it's referencing the owner object. So whatever object it is currently contained inside. So when you reference this, this is literally saying, it's almost the equivalent to saying person dot name, right? But it's actually in reference to the object it is currently contained in. So if I return this dot name, it will return Humphrey Bogart. This dot age will return 79, and this dot dob will return 1940 May 6th. Okay. If I want to execute that bio function and actually show what it does, I just call it just the same as I would call any function. Only I'm going to go person.bio, right? So person is the object, bio is the property, and then to execute it, I'm going to use a set of parentheses to execute it. Now I want to actually see that inside my console, so I need to wrap it with a console. So I'm going to say console.log, wrap the whole thing, like so, end it with a semicolon, and then click execute, and now we can see Humphrey Bogart is 79 years old. They were born on 1940 May 6th. Cool, eh? Pretty simple stuff. It's not really that difficult. Objects are pretty easy. At least object literals. Object literals are pretty easy. Object constructors get a little more difficult. But as you can see, it's not too bad. Now, adding properties to an object externally is just as easy as adding it internally. So when you add them inside the object structure, inside the object syntax like this, it's adding the properties internally. If I want to add them externally, it means I've already defined my object, and now I'm getting ready to add a new method or a new property to it. So for example, if I wanted to add a new property to it, I just simply reference person, press dot, like so, and then I add my new property onto it, and I make it equal to whatever value it is that I want. And that value can either be a string, a number, array, or an object, or it could also be another, like could be a function definition, which would essentially render it as a method, right? Pretty simple stuff. So in this one, I've actually copied this in for you. So this is a reference to an environment variable called person. It's a reference to this person that we've actually created. So make sure you've clicked execute in this one here, because if you haven't, this will be undefined. So you need to make sure you click execute. So this is our person object, just like we had before, and you can see that if I click execute, you can see there's our person object. We have Humphrey Bogart, his age is 79. If you click the down arrow, you can see all the different details. There's this bio, which is a function, right, that we have access to. So we're going to create a new property on person that stores their height in centimeters. Okay, cool. So we're going to say person.height, right, or whatever you want to call it, doesn't really matter. And I'm going to say 173. Now I'm not going to write centimeters because I want to be able to actually convert the height, so I don't want to have a word like centimeters on there. Otherwise I would have to trim it off or do something with it to replace it. I mean, it's not necessarily a bad thing. Is it a bad thing if I wrap this in quotes? Does that break stuff? Yes, so it's looking for height is not a type number, so it looks like my my logic is a little restrictive. So we'll make sure this is type number so it doesn't freak out. There we go. Now it's undefined is of type undefined. Okay, that's totally fine. That's unrelated to what we're doing. All right. Now we're going to create a new method on a person below that converts that height to inches and basically returns it back. So we'll say person dot, why don't we say height to inches. There we go. And we'll make that equal to a new function definition. And we don't need to pass a parameter on that because we can actually access this parameter by simply typing in the height. So I'm going to say return this, right, because this is going to refer to our owner object, this dot height times, and I'm going to multiply it by, I can't remember what it was. It was like 0.39, yeah, there it is. 0.393701, and that will actually convert from centimeters to inches, like so. And then I'll click execute, and it looks like everything is okay. Now I want to actually see that, so I'm going to create a console log. We'll do console.log person.height to inches, and make sure we put the execution brackets in, click execute, and there we go. So If you take 173, they're 68 inches tall, right? So if you wanted to know how tall that is, you could take 68.110273 and divide it by 12, and they're 5'6", almost 5'7", and that's roughly how tall I am. I think I'm 173.5 actually. So if I click execute and I take that one, it's like 3071235 divided by 12. Yeah, close enough, right? 5'6". All right. Now, the problem with this, though, is every time I want to create a person, I would have to duplicate this whole logic. Now, I could say let Sean and then write out this information, but then there's no normalization, right? I'm not forcing a user to define name, define age, define DOB or bio. I'm not forcing them to do any of that, and I would have to rewrite this bio function literally every single time, which is goofy, right? That doesn't make sense. It's not very dry. Plus, if I wanted to change something and add more functionality, I'd have to go into each one of these instances of people and add it in, and that's just tedious and doesn't really make a lot of sense. So we have this thing called function object constructors, and basically what an object constructor is it allows us to take an object and create almost like a template of it. Now, the interesting thing about object constructors is they're just functions. They're just a standard JavaScript function, and any JavaScript function can be an object constructor. It doesn't matter what you're doing inside of it, you can turn it into an object constructor entirely. However, the one thing to know is that you also get that wonderful power of this inside that function. So you can actually do things like this.prop1 equals prop1, which means now a person can pass in these arguments, and then you can assign these arguments to properties of this particular object. And that makes it super, super powerful. And then when you add in something like prototypal inheritance, then it gets even better because now you can inherit from other objects and so on and so forth. But let's keep this simple, just keep nice baby steps, right? Let's do an object constructor. So right now we have, let's dry up our person object by converting it into an object constructor. Call the function person, define 3 parameters, name, age, and DOB, and create 3 properties using this to store the past arguments when someone instantiates our constructor. Okay, so cool, we can do that. So first of all, we're going to create a new object constructor. Well, you already know how to do that because last week we learned about functions, so this is an extremely easy process. So just type in function, person, right? Just like you would create any function. There's our parameter list parentheses, and there's the body of our function. Now in here, we need our 3 parameters. So we need name, age, and DOB. And those are our 3 parameters, right? Now we want to actually set those parameters, so we're going to do this.name is equal to name, this.age is equal to age, and this.DOB is equal to DOB. Cool, right? Now we had a bio function as well, and there's no reason why we can't have the bio function available to us in here as well. So we can just say this.bio is equal to another function inside here, right? And we can go ahead and copy that code that we wrote up here. Where is it here? This code right here. Let's copy that down into here like so. Bam. Why don't we also, while we're at it, add this.height, right? And we'll make that equal to height, and then we'll add a 4th parameter called height. Oop, make sure we add the comma. And then we'll also do our to inches, right? So this height to inches equals function. And we'll return this.height times that. Cool, there's our wonderful giant function constructor. So we created a function called person, name, age, DOB, and height, this.name. We set all of these properties, this bio, this height to inches, all of that is done. Very simple, just basically a function. The only difference is that inside our function, we can actually create new function definitions and create wonderful properties in here as well. Now, if I want to instantiate 2 new people using these construction, that's not hard to do. We can definitely do that. That's easy. All we have to do is first we should store them in something, right? So why don't we do why don't we use Deep? Deep, right? Equal new. So we're creating a new object from this particular object constructor. So we're going to say new person. And then we have to give the constructor, because that's what's essentially happening here. We've created a constructor. This constructor is requiring these 3 things. You don't actually, just like most things inside JavaScript, you don't have to do this. You could just say let Deep equal new person and click execute. But you are going to have a syntax error because I'm looking for specific things in your instantiation. However, that is perfectly legal. Like, this is legal code inside JavaScript. There's no problem with that. I can show it just to prove it. We'll copy the function out. We'll put it right directly in here, like so. And then I'll create a new one, like so. And you'll see there's no error. It doesn't blow up because you didn't add in your arguments. None of this has actually occurred, though. That's the only thing to note. Because if you look at the Deep and you spit it out, you'll see that everything is just currently undefined, right? So you're not going to be able to actually work with any of the information yet. That's the downfall to that, right? All right, so if I execute, I have an error in my instantiations. That's not a problem. So why don't we fix that by actually adding in some information? So the person's name is Deep. Their age is, we'll say they're 23. And their date of birth, we'll just make something up. Minus 23, there we go, is 1996. So we'll say 1996. Let's do September, and let's do 30. There we go. All right, now we also need their height. So we'll say they are, I don't know, let's go 170, let's do 170 centimeters, like so. And then we'll create a new person. We'll do Thomas. Thomas equals new person. Thomas. And we'll say Thomas is 27. We'll say their birthday is 1992. And make it July. And yeah, I apologize if my math is wrong here. What do you expect, right? 178 centimeters. So, and then we should probably console log these out because we have no idea what they're going to look like. So let's do console log for Deep. Actually, why don't we actually console log out their actual methods? So we'll do Deep.bio, right? And we'll do console.log Deep.height 2 inches. So you can see that one as well. And then we'll do the Thomas one. We'll do console.log Thomas.bio and console.log Thomas.height 2 inches. Definitely need to turn on code hinting in this application. All right, cool. So we have instantiated our new people using the new keyword, right? New keyword makes it very easy to instantiate a new person. So we're instantiating our new person, Deep. They're 23, they were born this date, and their height is 170 centimeters. And then Thomas is 27, born this date, and then his height is 178 centimeters. Now we're calling our functions, and we're going to console log out their return values, right? Pretty easy. Hit execute. And sure enough, there we go. So we have Deep is 23 years old. They were born on 1996-09-30, and they are 66.92 inches. And Thomas is 27 and born then, and he's 70 inches. All right. So very, very simple. That's really all I have for you today. We are going to deal with object prototypes next week. I find that taking this extremely slow will allow you to be able to practice it and kind of get used to how objects actually work. They're pretty easy. You can also pass objects around in JavaScript as values, which is really neat. One I don't know, common use case is if you have a lot of values that you need set or that are optional and you don't necessarily want a core user to have to figure out what those are, you can actually create an object. So for example, what I could do is say I had a function, and my function was Sean, right? And inside Sean, actually, why don't we call it something different? Let's call it build person. And inside here, I'm looking for properties. Okay, and then I'm going to just console.log my properties. Okay, so now with properties, what I can do with properties, actually, let's make this a little better because this is not very good. Why don't we say console.log, actually we'll return instead because I like returning. We'll use our string interpolation because practice with string interpolation is always a good idea. And we'll write properties.name is $properties.age years old. They were born on properties.dob. There we go. Alright, that's a better function. So now, with build person, all I need to do is I'm going to store this person. So I'm going to say let Sean equal build person. And then I can pass in an object literal, like so. And I just have to make sure that each of these properties has been listed. So I'm going to say name is Sean. I'm going to say age is 40. And I'm going to say the DOB is 1978, 12, 22, like so. I hit enter. Now if I look at Sean, I get back this wonderful sentence. Now, you might say, well, yeah, so what? That's no different than if I was to pass those three parameters. But it is, because if I was to take Sean, why don't we create a new person? We'll call him Dave. You know what? Let's commit to it. Dave. Hello, Dave. So build person. Only this time I'm going to do, we'll do age is 40. Actually, we'll say his age is 35. We'll say he was born on 1984. Oops, 1984, 04, 04, 05, we'll say. There we go. And then his name is Dave Collins. There we go. Close my object, close my parenthesis, hit that, and boom, and then I type in Dave, and you can see it hasn't changed. Everything is good. Because this order is completely irrelevant. It doesn't matter what the order is because we're using properties, right? We're only passing one object and we're just referencing it from the properties object, which makes our lives a lot simpler when we're trying to work with large amounts of parameter list, or maybe they might be optional, right? So maybe we want some defaults in place. So for example, if name hasn't been set, maybe we want to default to something else, which we can do fairly easy. Like for example, I can show you that as well. So let's just rewrite our function here. Let's say if their properties name, right? Or we can actually write an or in here like this, just in line, or we'll call it default Dewey. There we go. So either their name is the name they pass in, or their name is default Dewey. We're going to hit enter. And now we can actually go ahead and call that. So we'll say let default, default Dewey, let default equal build person. And this time we're only going to pass in the two parameters of age. So we're going to pass in age. We're going to say his age is 56, and he was born, I don't know, let's do 1745. There we go. Obviously this math is terrible. Okay? Now you can see I've only passed in these two properties, right? I'm not passing in name at all because name is optional. I don't have to. I'm going to hit enter, and now if I type in default Dewey, you can see it says default Dewey is 56 years old. And that's because property's name, what you see here, it wasn't defined, so it technically is falsy, so it automatically goes with whatever the true side is, which happens to be default Dewey. And just to prove that that is the case, if I take default Dewey and I add his name in place, or even her name, let's make it a her name. We'll say her name is default Daisy, like so. When we hit enter, you can see now that it comes back with default Daisy is 56 years old. All right? So that's kind of a cool thing that you can do with objects. Objects are extremely handy when you're working with like large parameter lists and you're not really sure whether or not A, they're going to have default values, so they might be optional, or B, what order the user might put them in, because they could be in a wide range of orders depending on how many options you might have. You can generally see this when you start working with libraries like high charts, or even like some of the jQuery functions have options in them. You can see that when you're working with these like large plugins or large libraries, that they use options as like an object as the argument, because it's much easier to work with the object than it is to work with a very large parameter list. You can also use it to your benefit, where you require an object, but then you also require these few things that need to be set as well. So you kind of shrink down your parameter list to like 3 required values, with the object basically taking place of any default values or optional values, right? So now that you're done all of that, all of this has been done, it's all executed. All you have to do is click Get Code, go ahead and start at the top, go right to the bottom, hit Command-C, go over here, go to Labs, right? Click on Lab 4, click on Write Submission, paste that in there, right? Should hopefully look nice and neat. If it doesn't, it's fine. It's fine if it's all compressed. It's fine if it's not on, if it's all on one line. I'll fix it. It's not a big deal. Don't worry about it. And then just click Submit, and then your thing will be submitted, and I can go ahead and mark it. There's possible 15 points in total for it. Let me just make one quick change so that you can see me do it. We're going to say that the lab is not due on the 28th. Sorry, it's not due the 3rd. We're going to make it due the 10th. So there we go. We've extended it by 1 week. And the quiz, the test options. The quiz, oh, it should say show instructions. Good thing I opened that up. We're going to make it due not the 29th. We're going to go to the 26th. No, why did it go back in? Oh, no, that's way too far. We're going to make it due the 5th. Yes, the 5th by midnight. I think that's pretty good. Let me just double check, because now I'm concerned that I pressed the wrong date for the lab. I wouldn't put it past me. Edit. No, the 10th. No, that's good. Yeah, the 10th works. So it gives you quite a few days to get it done. Alright, cool. So, yeah, go ahead and submit that. Now, we're not done yet, so don't like, close the YouTube video yet. Let's talk about the assignment real fast. So this is the assignment. I don't really like writing big rubrics, so I didn't really create a big rubric for this one. So if you click on here and you go to View Rubric and you're expecting something, you'll only see Define Functions and Game Design and Functions. So Define Functions makes up 60% of it, and the Game Design and Function makes up 40%. The total mark value of this is 20% of your final grade. So it's definitely, I wouldn't delay on it. Like, do it right away. You have a ton of time. I'm not going to give extensions because, I mean, it's January 29th and you have to February 25th, which is almost a whole month to complete it, which should be more than enough time considering the size of the assignment. So here's the assignment, right? And you're going to see the detailed rubric is on this page of the assignment. So you'll need to open the PDF. So there's 6 functions altogether. There's 5 functions technically. There's random number, evaluate guess, reset board, a hint, the basic implementation, hint, to take it further, which if you don't do it, you lose 10%. And then there's the process guess, right? So the game design, the way it works is if the game works, then you get the 15%. As long as all these different things work, you'll get 30%. And then if you style it nice and neat, you can get another 10%. So it comes out to about 100. I do award almost up to 10% bonus mark if I find that you've really stepped outside the box and not just done the steps, but implemented some cool logic, done some extra things. Then I'll give you a few more marks. This whole thing will only covers basically these 6 weeks. There is an event binding in it, but you're not required to do the event binding. I'm doing the event binding for you. Sorry, 1 second, I'm just going to pause. Coughing out my lungs. Alright, so I'm doing the event binding for you. You don't need to worry about that. You just need to make sure those functions are in place. Now, if you don't want to use my script and you want to write your own, that's fine. But the logic has to be there. The same logic has to exist. You can't change the way the logic works. So I'll show you how it works, basically. Alright, we'll go open it up. So here's the JavaScript game. I haven't added any styling to it, but basically the way it works is guess a number, right? So you're going to guess a number. So I'm going to say 45, and I'm going to click guess, and it's going to say 45 is higher than the secret number. This part is the basic hint. It's either going to say higher or lower. That's it. That's all it does. The take it further will do this kind of thing where it says you are within 10 of the secret number. So if 45 is higher than the secret number and I'm within 10 of the secret number, then it means it must be between 35 and 45, right? So I'm going to say, let's do 37, right? And click guess. And it says 37 is lower than the secret number. You are within 5 of the secret number. So now it's reduced it down to 5. But notice that's not the only thing that's actually happening over here. It's showing a score. The score is at 8. And we've gone down 2 points now, right? And it says you have 8 guesses to get it right. So that's the maximum score I can receive on this is 8. So we're going to say it's within 5. And it's lower, so 42 would be the upper range. So why don't we just try 40? And click guess. Great guess! I won! Guess the new number. So I get 8 added to my score. So now I have 16, right? And then I can continue to guess and keep doing this, all night long if that's what I want to do. So this says I'm within 20 and it's lower. So it's between 56 and 76. So why don't we say 66? Wow, that was awesome. That was a wicked guess. So I got 24 because I basically added 9 to my 16. Anyway, so cool. So that's what you're going to build. It has to have this basic logic. The way it actually looks, I'm going to open the student one for you so that you can see. Alright, you're going to see a few files in here. There's a Sean code file which is in here to help you out. Basically the Sean code file will evaluate as you write these and give you some feedback and some hints. Now if you need more information outside of those hints and feedback, please contact me on Slack, right? That's the first place. If you haven't added Slack, I recommend adding Slack. Most of the industry uses Slack to communicate. They unfortunately don't use Discord that much, though I do like Discord. But they use Slack. So get used to using Slack. It doesn't hurt to have it. Plus the feedback and the peer assistance is definitely worthwhile. So that's the first way to contact me. Otherwise, you contact me by email, which is literally the slowest way to contact me because every so often Georgian changes my password and I don't find out for like 5 days, right? So I won't get your email. So use Slack. Slack is definitely your best bet. All right, so you're going to write a random number function that returns a value between 1 and 100. And your first question is going to be, how do I write a random number function? And I'm going to say, go to the internets and type into Google literally JavaScript random number between range, like so. Oh, cool. Look, on MDN, our wonderful textbook. math.random. What is this big damn advertisement? That's nice. All right, and if you scroll down, you can see, oh, here's one. Get random arbitrary for min and max. Now, this one's going to do it, and you'll likely wind up with a decimal. So you want to do this one, which will do seal and floor for you. And this will definitely give back an integer, right? Because this one likely will return back a decimal. This one will return an integer. So I would use this function. You are welcome to copy this function and paste it in here. Just make sure that the function name is random number, okay? Because if my code executes and it doesn't fire off your random number function, I gotta go find it, you're gonna definitely lose a mark on that. So now store the following 5 elements using the correct visibility scope and selector. I know you don't know how to do this yet, but you will know how to do this in 2 weeks on how to do this particular part, okay? Initialize the following variables using the correct visibility scope. Initializing variables you should already know how to do. We did that in week 1. Create a function that compares the user's guess to the current number and returns a Boolean value. This is a simple one line of code that you need to do that will return back either true or false based on the idea of whether or not their guess is equal to the current random number. This one's a little bigger. You're going to create a function that basically resets the board and call it reset board. But all you're doing is resetting these 3 things back to what you initialized them with. So guess limit, current number, and then this input you're going to set its value to a blank, obviously. Then you're going to create a function that will provide a user a hint if they get the wrong answer. Call this function hint. This is the big hint function. If you do this part here, the maximum you can receive on this assignment is 90%. If you do the take it further part, this whole part here, then you can receive up to 100%. Just a note, I just realized something. If you don't want to do take it further, you're going to need to comment out this diff, or it's going to throw an error. Okay? Let's progress. So the last thing you're going to do is the process guess. This is basically your game logic that's going to take all these wonderful functions you created above here and put them all together, as well as allow you to change some messages and stuff and provide some information back to the user. All right? The whole process, 119 lines, probably take you, depending on your skill level, anywhere from 45 minutes to maybe an afternoon. If it takes you longer than that, that's totally fine. Now, I do believe I did something I don't generally do, and I made it. Yes. All right. So, yes, you may create your own number guessing game from scratch. It must meet the requirements outlined in the rubric, though. The functions don't have to have the same symbol names, okay? But it has to meet the function requirements outlined in the rubric, and I need to know in advance, please, that that's what you're doing, okay? And yes, you may work in groups of 2. Only 1 submission per group with a file stating who your group member was. That's super, super, super important, because if you don't, the person who submitted will get the mark and the other person will receive a 0, and they're likely going to be mad at you for that. So make sure that both group members are posted in the file. It might seem obvious, but I mean, I do this constantly in different classes, and whenever I do group stuff, I get one file from one person and nobody in their group, and I assume it's them. And then I find out like a week later that 3 people are pissed off because they didn't get their mark. So make sure you don't do that, okay? And then last, this big note. Because this is a very common assignment, your code will be run against Google search to verify it is your own code. I do this, and I know it. Like, I immediately know when somebody has copied Google. It's so blatantly obvious to me, it's not even funny. So don't copy Google. I won't report you. I'll just zero out your stuff, and you'll fail my class very fast. I guarantee it. And I'm sorry if I sound a little annoyed about that, but people do it to me all the time, and it irritates the shit out of me because it's so stupid. Don't cheat. Just try it, because you stand a better chance of getting a better mark if you put some effort in and give it a go. Now, effort obviously means, like, you know, try to make it look nice. Don't just change the background color. Try to make it look nice. Add in the functionality that's required. test your code. That's the big thing. Test your code. Create the function. Run the function in the console. Make sure it works before you just post it in. Don't just hand me a ton of broken code, because if you hand me a ton of broken code, I kind of consider that the same as throwing paint at a wall and saying you painted your house. So just please make sure you actually code properly. Test your stuff out. If the game doesn't work, that's okay, providing you've tested out these other things and they are working. Okay. Yeah, that's basically it in a nutshell. It's due on February the 25th. Yeah, that's it. I hope you guys have a great night. It's 9 o'clock. It's a nice short class. Yeah, cheers. I'll see you next Tuesday.